Okay guys, today in precalc we're going to do a little review and also going to teach you how to use some problem solving techniques to do radicals. So let's do a little review first. Let's say that you just had 2 times the absolute value of x minus 3 is equal to 8. All right, I don't know if I mentioned this to you before, but whenever you're solving an equation, you're doing PEMDAS, but you're doing it backwards. So you do any adds or subtracts, you handle any multiplies or divides. If there's any exponents, you do those second to last. And the last thing you do is get rid of the parentheses or the grouping symbols. Remember, I said this is like GEMDAS, G for grouping symbols instead of parentheses, because these are grouping symbols. All right, so I'm going to start by, can I do any adds or subtracts? Well, let me just cheat and make there be an add in here just to make the point. If I did have a minus 1 there, I could get rid of my adds and subtracts first. Add 1, add 1. And then I have 2, absolute value of x minus 3 is equal to 7 plus 1 is 8. All right. Why don't you pause for a second right here and see if you can finish this one up without my help. We'll see if you get the same thing I do. Okay, let's see if you did it the same way that I did. Absolute value of x minus 3 is equal to 8 divided by 2, which is 4. And then we're going to split that into 2 equations. X minus 3 is 4, and x minus 3 is negative 4. Because what's underneath here, what's in here, could either be 4 or it could be negative 4. That's why we have to set it to 4 and to negative 4. Then we're going to add 3 to both sides. Add 3, add 3. Now that brings us to x equals 7, and x equals negative 1. You really should check these at the end, and that's even more important today than ever before, because sometimes your answers just don't work, and we're going to probably do that to you on your test, where one of your answers on one of your problems isn't going to work. Like you could have followed all the steps right, and it still doesn't work. Let's see if 7 really works. I put a 7 in here. 7 minus 3 is 4. Absolute value of 4 is 4. Times 2 is 8. Minus 1 is 7. Yay, it worked. And pausing for a sec. Sorry about that little interruption. All right, so now I just verified, I think, that 7 worked. We put it in and it actually came out to the right answer. Now we can put in negative 1 and make sure it works. Negative 1 minus 3 makes negative 4. And when you absolute value that, you get 4 just like before. And so since I get 4 in here again, I times it by 2, that makes 8. I subtract 1, and that makes 7. It worked. Yay. Now I'm pointing this out because when we solve radicals today, there's a lot of times where you can follow all the rules, and the radical, for some reason, still doesn't work. Like you get an answer that does not actually work when you put it back in. And that means that that answer that you have is not a correct answer. There's a name for it. And it's called a extraneous solution. All right, so let's say that I had a 4 here. If I'm going to solve this, it's going to be just like what we just did. We start with, PEMDAS. So when we're doing equation solving, we're going from the bottom up. So we start with add and subtract. Add 4 to both sides. 2 times the square root of 2x minus 1 is equal to 4 plus 4 is 8. Divide by 2, divide by 2. Square root of 2x minus 1 is equal to 4. And right here, we square both sides. When you square both sides, that removes the square root here, and I end up with 2x minus 1 out from under its square root. And the 4 squared is 16. Then I'm going to add 1 to both sides. and 2x is equal to 17. Divide by 2, divide by 2. 17 halves is my final answer there. All right, so can you do it? I'm going to give you one now, and let's see if you can get the right answer. By the way, if I put that 17 halves back in here, let me just show you that you should really check these. If I put 17 halves in there, this 2 cancels this 2. 17 minus 1 is 16, and the square root of 16 is 4, times 2 is 8. 8 minus 4 is 4. Yay, it worked. 17 halves was the answer. Okay, so I'm going to give you one. 3 square root of x minus 9 plus 2 is equal to 14. Yes. All right. I'm going to pause for a second, give you a chance to try this one, and then we'll compare notes. Okay, following our PEMDAS backwards technique, we got to do our add subtracts. We're going to take away 2 from both sides. 3 square root of x minus 9 is equal to 14 minus 2 is 12. And then I'm going to divide by 3 on both sides, and that's going to leave square root of x minus 9 is equal to 4. And then I'm going to square both sides, and I'm going to have x minus 9 is equal to 16. Add 9, x equals 25. If I'm going to be extra careful, which, my grade depends on this on a test, I would probably want to go and check 25. So if I put in a 25 right here, what is 25 minus 9? That's going to be 16. Square root of 16 is 4 times 3 is 12 plus 2 is 14. Yeah, I checked it. It works. All right. So what would happen if it didn't work? If it hadn't worked, I would cross it off and write ext for extraneous. And that's not the case here. This one did work. I'm just trying to show you what you would do if you got an answer that when you plugged it in, it didn't actually work. All right, so there's one last kind I want to talk to you about, and that's like this. Let's say I have x minus 3, and when I get it all solved, I have like an x plus 3 on this side of the equation. And at that moment, when I've got this alone, now I'm at my part where I'd square both sides. So I'd square this and square this, and this is x minus 3, and do you remember that this is not x squared plus 9? It's x plus 3 squared, which means times itself. So that's really x squared plus 3x is 6x plus 9. And then I have to get this all to one side, so I'm going to take away x from both sides. Negative 3 equals x squared plus 5x plus 9, and then I'm going to add 3 to both sides. The point, I'm trying to get this equal to 0. All quadratics should be set equal to 0, and then if you can factor it, you should. Now, this 12, lots of different ways to make a 12, so I could definitely try to factor this thing. But I did not preset this up ahead of time to factor, so it might factor. I'm checking through some options. Since there's only pluses in it, I'm going to use plus and a plus. Then it could be 12 and 1, but that's not going to make a middle term of 5. It could be 3 and 4, but 3 and 4 also doesn't make 5. It could be 6 and 2. That also doesn't make a 5. Like if I put a 6 and a 2 here, the outside and inside is really where it's at. 6x and 2x, and that makes 8x, not 5x. So this one won't factor. And if it won't factor, does that mean you get to just say there's no solutions? No, not at all. It's time for the quadratic formula. So if you ever get one that you get to this part, frankly, usually they're going to factor. But if it doesn't factor, that's where you got to say, okay, I'm going to bust out x equals negative b, in this case negative 5, because that's the b term. There's a 1 for the a term, and the c term would be a 12. X equals negative b plus or minus the square root of b squared, which would be 25, minus 4ac, 4 times 1 times 12, all over 2a, which is 2. So 25 minus 48, oh my gosh, I got a negative square root. A square root of a negative. Do you get that this number is much bigger than this number is? That means I have a negative under the square root. That means there's no real solution. If you've got a square root of a negative anything, then you don't have a real answer. You have an imaginary answer. So you'd say no reals. Okay, that got pretty intense. I think we should do the first problem on your worksheet together. So I am going to pull up that worksheet. And, okay, actually the first question is just a complete review question. Let's do the first one that's got a square root in it. It's number 5. So let's do number 5 together. It says x equals the square root of 3x minus 2. All right, so if I were you, I'd get your worksheet out here and start working through them. I'd start with number 5 with me here. I'm going to square both sides because that gets rid of the square root. X squared equals 3x minus 2. And then remember to set it equal to 0. Minus 3x plus 2 equals 0. I did a quick minus 3x on both sides and a plus 2 on both sides. And now, if you can factor it, you should. And this, I have a minus here and a plus here. That's a tricky one. There has to be a negative. But in fact, there has to be 2 negatives because that's the only way you're going to get a positive number there is if both of these numbers are negative. So now, well, it's really only one choice. It's got to be 2 and a 1. So then I get negative 2x and negative 1x makes negative 3x. Yay. So my answers are x equals 2 and x equals 1. And those are my 2 solutions. Now, you remember me saying that there could be a scenario where these don't check out. When you go put them back in, they don't actually work. Well, let's find out if this one does. The original problem was x equaled square root of 3x minus 2. And if I put a 1 in there, for instance, I put a 1 right here and a 1 right here. This is the square root of 1, which is 1. So that one worked. Let's just try 2 real quick. 3 times 2 is 6, minus 2 is 4. Square root of 4 is 2. Yeah, they both work. I'm warning you, though, there's going to be problems where there are extraneous answers. Like when we check one of these and they doesn't actually work, then you got to cross it off and write EXT for extraneous. All right, but on this problem 5, they both worked. All right, I think the rest of them should be good practice for you. The answer key should be posted. I am still feeling pretty crappy, but I hope you appreciate my attempt to teach you here today and get you some learning from the person you're used to the most this year anyway for math. And it would have been very tempting to just try to find another video somewhere, but I felt like I needed to teach you myself today. Take care. Bye-bye.